So, hello everyone. Let's talk about today's Geeks for Geeks problem of the day. So, the problem statement is let's see what is the problem statement given to us. So, we have given an head of the linked list where the nodes can contain the values zeros and ones and twos. So, there is only three values in our linked list: zero, ones, and twos. Your task is to rearrange the list so that all zeros appear at the beginning, followed by all ones, and all twos are placed at the end. So, in simple manner, you have given a linked list with a value zero, one, and two, and you have to sort that linked list. Sort that linked list means the zero will appear first. Suppose you have given this linked list zero, 1, 0, 2. So what you have to do, you have to first write the 0. After that you have to write 1 and you have to write 2. Okay, so this is all about the problem statement we have given. So how will solve this problem? There is one more interesting problem similar to this, which is an array. Sort array in 0, 1, and 2. Sort 0, 1, and 2, something like this. So there is one famous algorithm which is Dutch national flag. Uh, so do check that problem as well. Let's discuss what is the first approach for solving this problem. So what I'm saying, if as we have only three values 0, 1, and 2, so we will keep a three variable, which one for 0, one for 1, and one for 2. And what we'll do, we'll count the frequency of this all the element and we'll start filling linked list again with a 0, 1, and 2. Let's discuss with the example. Okay, what is the example we have given? 1, 2, 2, 1, 2, 0, 2, 2. 1, 2, 2, something like 1, 2, 1, 2, 0, 2. Okay, so this is the example given to us. So what we will do, we'll count the frequency of each number. So I'll count the 0 first, I'll count 1 and 2. Initially all the frequencies are 0. Okay. So first my head will point here. Okay. So instead of head, I'll write H. Okay. So my head will point here, or I'll keep it as. So head will point here. So what is the value of this node, which is 1? So I'll increment the 1 frequency. Then my head will go to the next. What is the frequency? What is the value of this node, which is 2? So my frequency of 2 will be increased by 1. Again, what is the frequency of this 2? What is the value of this node is 2. So my 2 frequency will increase by 1. After that, what is the value of this node? 1. So my 1 frequency will be increased by 1. So it will become 2. Again, what is the value of this node is 0. So my 0 frequency increased by 1 and it will become 1. Again, what is the frequency of this? What is the value of this node, which is 2? So my frequency of 2 will increase. And what is the value of this node? It is 2. So my frequency of 2 again increase. So now I have three frequency 0, 1, and 2. What I'll do, I'll start filling my linked list again. Now how I will, until I have 0, I will just fill the 0. So I have 0 and I will remove the frequency. Now until one node becomes 0, I'll start filling overwrite this node. So what I'll do, I'll write 1 here, I will write 1 here, and it will frequency might become 0. Okay, now I have remaining frequencies are 2. So I'll start overwrite this frequency as well. So it will become 2, it will become 2, it will become 2, and it will become 2. Now it will become 0. Okay, so now we achieve our linked list by using only these three variables. So this is the very simple and easy approach. So let's code it. What is the time complexity of this approach? The time complexity of this approach. Let's see the code and after that we'll discuss the time complexity. Okay. So what I'll do, I'll take a three variables. Integer 1 is equal to, okay, I'll start with the 0. Integer 0 is equal to 0, 1 is equal to 0, and 2 is equal to 0. Okay. After that, until current, just start filling. Okay, if current dot data is equal to 1, 1, sorry, I'll start with the 0, I forget the 0. O plus plus, Z, Z plus plus, I write the 0. No, it's okay. LC current data is equal to 1, start with O plus plus, else T plus plus. Okay. Now what I'll do, I'll again fill that node star current is equal to head. So no need for the node star because I already have current. And again while z until 0. So we will just remove the z and we'll just add the current data is equal to 0 and current is equal to current next. Okay, similar for 1 and 2. Just make it here. We'll just increase the screen. Okay, so this is 0, this is for 1, so I'll instead of z I will add o here, and instead of I will add here then 2, then this is 2, and here is a 2. Okay, and after that I'll return the head of the linked list. Let's see it will work or not. If we get any error, we'll fix it. Okay, it give the time limit exceed because I won't increase current here. Current is equal to current next. Let's see what is the wrong in this code. As again, no, there is no wrong. So yeah, it's passing the example test case. So let's submit it. Okay, so yes, it's get accepted. So what is the time complexity of this loop? This loop is running big of n time. So this is the time complexity of big of n. Now that remaining 3 loops is also running big of n time. I can say why? Because it contain the frequency of each node. So we have n nodes. So we have n node. If we add all these node, like here is 1, 2, and 4. So what is become? It become 7. We have 7 now. 1, 2, 3, 4, 5, 6, 7. So it's same similar to the big of n because it will run its own frequency time. So overall, if we calculate, so it will run big of n time. So what is the overall time complexity? Time complexity overall is big of n plus big of n. And what is the space complexity? We are not taking any extra space. We are just using the constant variable. So it will big of 1 time. Okay. So this is one approach. Let's discuss another approach. What is the second approach? Instead of using variables, we will create the separate linked list for these variables. Like what I'll do, I'll take this example. What is the example? I'll take this example now 22012. Or I'll modify it. Suppose I have some linked list like this 2, 2, 1, 1, 0, and 0. And after that, this null. Okay. So what I'm saying, I'll create the linked list for 0. What is the 0? So I have only 2 zeros. And then okay, I'll create the linked list for 1. And I will create linked list for, and after that what I'll do, I'll just merge all these linked lists. Like I will point this 0 node, next is this node, and this 1 node next is this node. So it will become something like this. Okay, if you write this, it will become 0, 0, 1 1 and 2 and 2. So achieve the same thing using, if the interviewer say you can't overwrite linked list values, so you can use this approach. So this is also a simple and easy approach. Let's code it out. And also there are some sorting algorithm. You can use the any sorting algorithm. The time complexity of average, the minimum time complexity of the sorting algorithm is n log n. So if you can't do this, then you can use the sorting algorithm as well. Or you this is the time complexity of big of n and the space complexity of big of 1. So you can use the sorting algorithm, their time complexity of big of n log n, any sorting algorithm to sort the linked list. And another approach is this. So let's discuss this approach code. So the code is also simple. What I'm saying, I'll just creating the nodes. Instead of these values, I'll just creating a linked list. So what I'll just do, I'll create a node for the 0 head and it will point to null, and again 0 tail, it will also point to the null. Okay. Now similar for the 1 head, it will point to null, and the 1 head 1 tail, it will also point to the null. Okay, next again node star, 2 head, it will point to the null, and the 2 tail, it will also point to the null. Okay, now what I'll just do, I'll create the current node, it will point to the head. Okay, while until the current is not null, what you will do, if the current data is equal to 0, then you have to insert the element into 0. So you just check if the t z, if z tail is a null, then you can just make z head is equal to new node current data. Okay, instead of current data, I'll just extract this value, because who write these things again and again. So instead of current data, I'll use the value now. Okay, yeah. So this thing, if and t head is equal to z. Okay, okay, else if this is not possible, what you'll just do, you just create a new head. New head is equal to new node of value. We'll just show the t tail next is equal to new head. I'm just simply inserting, and I'll mark the t tail is equal to new head, or I can say t tail is equal to t tail next. Okay, so here what I'll do, t tail next is equal to new head. Okay, so simply what I'm doing, suppose if my zero linked list is null, completely null, suppose z head is a zero linked list head and z tail is also the zero linked list head. So what I'm saying, if there is any value come with a zero, just create a new node and point as a zero. So I'm creating a new node and I'll pointing to the z node. So now what become, I have the linked list and the both pointing to z head is also pointing here and z tail is also pointing here. So if next time if it is come, if 1 0 is come, I'll create a new node of this 0, and what I'll do, I'll just say key, if I'll just check if z tail is not null. If it is null, then create a new node with and mark z head and z tail, point z head and z to the that node. But if this is not null, then what just do, z tail next to 1, because just insert this node to the next to this node. So after that what you will do, you will just update the z tail. So next time if the any node come, you will just extending from the z tail, so it will take a time big of 1. But if you are just iterating from the head, so it will go to big of n. If you are inserting element at the end, you'll just using the tail node, you will insert that element in big of 1 time. But if you are not using the tail node, then you have to insert this element in big of n time. So if you know the insertion in linked list, then this is very simple for you. Else if the value is equal to 1, you have to do the similar thing for all of this. So I'll just copy this code 3 times, because else. Okay, now instead of z tail, you just add the 1 tail here, voting, and instead of z head, this is o head. Instead of this is z tail, not t tail. Okay, sorry, my bad. T tail is 2. Okay, so this is Z tail. So what is, so one tail here, I forgot the one. Oh, okay, O tail, then O tail, and then O tail. One tail means, sorry, this is T tail. No, this is one tail. Okay, yeah. Now this is T tail. This is T head. This is also T tail. This is also T tail, and it is Z head. So it's D head. Now here it is O head. No, this is O head. Correct. So let me check this code again. So I'll just zoom it out. See, we created this node, then after that we just Z head, then Z tail to Z head, then Z tail to Z next. Okay. This is else condition. This is one tail, one head, one tail, one head, one tail, one head, one tail, one tail, one tail. Okay. Nice. Then again T head, T tail, T head. Okay, here's new head or new node. It is a new node. Okay. So I'll just do, after that I have to do the current next. So at the end I'll increment the current is equal to current next. Again what I'll do, now there is a three conditions. What is the three condition? Which is very easy. There is a possibility if Z is null, means we don't have the linked list. We have linked list like this 1 2. So here is no 0. So your 0 linked list will be the empty. Okay. Suppose you have a linked list like, okay, suppose okay, suppose you have linked list like 1 and 0 and 1, so you don't have a 2, so your 2 will be, 2 linked list will be the empty. Okay. And if you have something like this 0 and 2, then your one linked list like will be empty. So you have to just check the empty condition. So what you will do, if O Z tail, if no, not equal to null. Okay, means if Z tail is a null, okay, if there is some element like, I'll just say Z tail is not equal to null, then what to just do, Z tail next is equal to O tail, O head. But what happened if botnet and O head is not equal to null? This is the one condition. Okay. What is the second condition? Else, else just mark Z tail next to the, I'll just make it in simple manner. Okay. And after that I'll just do O tail next is equal to T tail and return Z head. Okay. Now if there is no Z tail, then simply check if there is a O tail. If yes, then simply mark O tail. I'll just return O tail next is equal to T tail, T head. Okay. So O tail next is equal to T head and simply return the O tail. Even T head is null, it doesn't matter. Okay. If there is no, then return the T tail. That means you have only values of 2. Okay. Now this is happen if Z tail is not present. Okay. And if the Z tail present and one head present, I will check this condition is here as well, end as well, because if O head is not equal to null, then do this. Then do these three things. Okay. If O head is null, then what? If one head is not present, then just return Z tail next, add just and T head and return this node. Even T head is null, it doesn't matter. And return Z head. Okay, now here I have to return one head and I have to return t head because head is containing the starting point. I'm not return. So let's see what happened. Let's see. If z tail is not present, then just check one head present or not. If one head is also present, then what just do? Add the three links. Z tail next is equal to one tail next is equal to two head, and return t head. But if one is not present, then you have to merge z tail with the two head. Means this is the contain the one and two. This code contain one and two. Okay, this contain one, two, and three. Okay, but sorry, zero and three. This contains 0 and 2. Okay, my bad. Okay, what happened here? If there is no 0 node, then check for the 1 node. If so, it will contain only 1 and 2, or it contain only 2. Okay, if there is no 2 node, it will also contain. If there is no, it will contain 0 1 on 0 1 as well. Okay, or 0 1 as well. Because if the two node is null, then it will contain 0 and 1 as well, and it will only contain 0 as well. Okay, 0 or 2 or 0 as well. It will contain 1 2 or 1 only, or it will contain 2 only, or 1, or I am saying or, and this will contain, and this contain 2 only. Okay, so this is all about the problem statement. So let's try to compile it. Hope it will get accepted. So if there is any error, we'll just check it out. Okay, z tail and z tail. Okay, so if there is mistake with the z tail, man, no, there is no mistake. So if z tail is equal to null, yeah, so I can say no, z tail is not equal to null. Z tail is not equal to null. Where is the z tail? Z tail, z tail is equal to null. Okay, I have to just add a star here. Okay, or it will become. Return the z. So the spelling of z is wrong. Some here. So okay, so it passes the example test. Let's try to submit it. Yeah, so it's get accepted as well. So what is the time complexity of this code? This loop is running big of n time. So the time complexity of this big of n, and again only we have only n nodes, so it will also go to the n time. So overall time complexity is big of n plus n. And what is the space complexity? The space complexity, we are creating a 3 new linked list. So overall space complexity of big of n. So this is all about the problem, and this is for today. Let's meet tomorrow. Goodbye for now. Bye.